Okay, today, so we're going to talk about scalars and vectors. That's the topic of today's lesson. It's really one of the first topics we're going to discuss here in physics. And the reason why we're going to go there is because it's a way to think about numbers. It's one of the first, and so that's where I want to start with our exit ticket, or our entrance ticket. So looking at this up here, you can see I've got my vector scalar summer lesson. I'd like you to go there on Google Classroom, and I'll open that one up in the main screen in a minute. So if you join my Google Classroom, you should be able to go to the vector scalar entrance ticket. Bam. So there we go. You can join me. And that should work great. And I'd like you to write your response in here. Oh, so joinpd.com. I'll put that in the chat over here. Let's see that. Okay, there we go. I got one in. Awesome. Two. Now I'll click start class on it. Get the link. Oh, yeah, there it is. Okay. Ooh, that's pretty handy. And there's the direct link. Okay. Let's go back in here. So start. So this is our entrance ticket. And let's see if the slide works. So you can, let's give me some, hopefully everybody can see this. Oh, and I'm looking at my dashboard now. And we can see what it looks like when we let's get some answers in here. The first question is, who went farther? Just take a few minutes, build out. I'll give you like 30, 40 seconds. Okay, so for those of you here, great. Now, I know it's not a big class, normally I wait a bit longer, but here's the question for you. Are the questions unambiguous? Or do you think you could come up with more than, mic's on, do you think you could come up with more than one explanation or a different answer? And those of you who love the sciences will hate this, and those of you who aren't good at the sciences will love this. Is there possibly more than one answer to these questions? Who thinks yes? Hands up if you think there's more than one answer to these questions. Okay, Pam, what do you think? Why?
My mic was mute. Yes, I think so.
Yeah, I got you. Why do you think there's more than one answer?
Goodness. I mean, because there's multiple ways of doing things. There's always going to be more than one answer, I think.
Right, and the fact that I've got two topics for today's lesson, yes. But thinking more specifically about who went farther, is there more than one way you can interpret that?
Being a math person, I'm thinking distance.
I'm going to go to Bill, and I'll come back to you, Pam. Bill, is there more than one way to think about that?
Yeah, I mean, because if you're running around and you're closer to where you began, then maybe you didn't go farther, or maybe you did.
Okay, and a way to illustrate that, I've got it over here on my whiteboard. Now, in class, those of you who are new should remember, you always want to have a sheet of paper, because if I write something down, you probably want to write it down too. And you'll notice the illustration I got here. I've got a square. Mary and Sean are both starting in one corner. Mary's line is in blue, goes around two sides. Deshaun's line is in red and goes around three sides. So from where they started to where they finished, who went farther?
Deshaun.
How do you figure? Farther from where?
From where they started.
If I told you, what, here's Deshaun,
Oh, I see what you're saying. No, I guess.
but here's Mary. Who went farther?
Furthest, right, because at a diagonal there, yeah.
Mary would have gone farther, right? Look at her,
Right.
she's farther away from where they started than Deshaun.
Right.
Yeah, but Deshaun also ran to that point, and he ran closer.
You're right. He ran there and back. If Deshaun kept running this way, oops, I should probably do that in red.
Yeah.
If Deshaun did this, and he ends up right back where he started, who's farther? And the problem is that we don't have a good answer for that because the words themselves are ambiguous. And as a physicist, we need to be a lot more specific because we need to be talking about what does it mean to go a certain distance along a specified path, or in other words, what does it mean to end up a specific distance away from where you started? And those are two different questions, and so that's what our lesson is going to be about today, the idea that these are two different ideas, two different ways of measuring a distance that you've traveled, even for something as simple as this. We could say, if this is 10 meters on a side, well, Mary traveled 20 meters. How far away is she from where she began? So we could say that she traveled.
Pam should answer that question.
Yes, she should.
Very funny.
She traveled 20 meters, but how far away is she from where she began?
You said, I'm sorry, 20, right?
From 0 to 20. Oh,
No,
okay.
that's not how far away she is from where she began. If this were a coordinate plane in X and
Right.
Y,
That'd be distance. That'd be
Right.
10.
it'd be 10 radical 2, so 14. So she's 14 meters away from where she started. 10 squared, 200 squared, 200 is a little bit bigger than 196, which is 14.1. So she's roughly 14 meters where she started. Now we can ask, how fast was she traveling? And you might say, well, okay, she did 20 meters in 4 seconds, 5 meters per second. Then we're just doing that with a quick velocity as distance over time, where we have the miles, or in this case, the meters, and the seconds. Okay, and just simple division. If you've ever seen a miles per hour sign, that's all it is. Okay, same idea. And we can say she went 5 meters per second. But what was her effective speed between the time she started and the time she stopped? Bonus for the first person to answer. I have no idea what the bonus is. I'll make up and be totally arbitrary later. So first one to give me an answer. What was her effective speed over her entire trip? Okay, short answer is if she went 14 in 4 seconds, it'd be about, not quite 3.5. You can see it'd be quite a bit slower. Why? Well, because she didn't go the straight path. She went out of her way. And so when physicists talk about this, we can describe these two different ideas of along the path and the direct line. But there's another, but why would we bother doing this? Here's the important question. What direction did Mary walk? And I'm going to start calling on people. What direction did Mary walk? Monty.
It didn't say.
Okay.
Just talk about
Yeah, we can assume that in here, we'll just give this an arbitrary cardinal direction, north, because people like that. Okay, we'll be wonderfully Eurocentric. Okay, north is up.
So the
If you walk.
But you asked, how far did she walk?
No, what direction?
But she's not walking.
Well, when she walked. What direction did she travel? Yeah, Phil?
to northeast?
North and then east.
North and then east. If you had to put it into a single number or a single direction, how would you express that?
Northeast.
Right. If I asked you, tell me how far and in what directions she walked, and I said she walked 20 meters, could you say she walked 20 meters northeast?
No.
Why not?
14 meters northeast. She walked 10 meters north and 10 meters east.
Very good. Very good. And that's the idea. We have to describe the motion in different ways, depending on what we want to do with it. Now, let's go back to the slide. Let's see how I get out of here. Let's go. Okay. Let's go on to the next slide here. Okay. So now we're going to go into some breakout groups here. You can this is the presentation. If you want to have a copy of it open for yourself, you'll see on the next slide. You should be able to click that. I think the link is set up that you can click it straight through. I'm going to split you up into breakout groups. And group 1, whoever's in room 1, it'll tell you on the sidebar. Room 1 will solve the first problem, and room 2 will solve the second problem. And the thing to realize here is that we're going to be measuring things at an angle. We need to find the total distance traveled. And I'm going to call this vector addition, and that doesn't mean anything yet, but we'll just call it that. Okay. So, everybody got the presentation open? Because I think I can breakout groups. Breakout groups. I want 2 groups. Groups. There we go. Okay. So mic's off.
Ethan, you're in my group.
Yep. There we go. So now you can share, and everybody should have a copy of it open. And this should let you see. You should be able to now, if you want to, you can use the whiteboard. I think that's strongly recommended. Or you can open up the presentations. Oh wait, okay. There we go. Is that right? There we go. There we go. Okay. Yep. That's what I get. Hello, Monty and Harm and Pam. Welcome to this group. Do you have? I'm going to go through the groups and make sure everybody's on the same page. Do you have this slide, the 2 problems open? This is group 2. So you'll be doing a second slide with a problem on it.
Right, is that the one with the trial 2?
Yep. Let me see. There's vector addition 1, and again, yeah, trial 2 and trial 1.
Okay.
All right,
So, are you doing trial 2?
yeah, you're doing trial 2.
Okay.
Okay. Yeah, I'm suddenly realizing that I can have multiple slides here, but I can't do pair deck through breakout groups easily. That's a pain in the butt because I can only display 1 at a time. So I'm going to leave trial 1 up here because it's got instructions on it. So you can solve that if you want to switch back and forth with your partners. So it's got the idea. And then, but I'm going to go back, but I'll leave this up. So you'll have to solve it on, you can either type it out or whatever you want onto the actual copy of the presentation. Or you can just put it on a whiteboard.
Okay.
Okay. I'm going to go to the other group. Thank you.
Right, Monty, I think we're in trial 2. I have to make
I see trial 2.
right. It says going 30 south first.
So start at the origin going 30 south,
Uh-huh.
and then we're going to go 15 east, and then we're going to go 15 north.
30, 15, 15. Okay, choose a starting point. Stick 1 pencil on the ground. Okay. Let's have it. Determine your ground plus. Using vector addition.
Okay, so
So you're halfway up the,
you're facing,
Right, so you're going 30 south, then 15 east, and then 15 north, so you are halfway.
halfway
You're going southeast,
halfway back, halfway up.
right, halfway up to where you were, right.
Well, halfway, so, and that would be 15. So, so you've got 15, basically you've gone half the distance to get back to the point where you would start.
Mm-hmm.
And you're, I do a dotted line on the rectangle from the starting
Right.
point
That's what I would do.
to the half. Oh, so I see. So you've got like, it's like
so we're going 15.
It's like a small rectangle, sorry, a small triangle.
Right, so it'll be 15 square root of 2 is where we end up
15,
southeast from where we were. 15 square root of 2. Later here, so
I don't know why you guys, okay, 15.
That'll be roughly 21, a little over 21. Is that miles or meters or whatever this were? That would be southeast from where we started.
So the question is, what is that distance of the hypotenuse?
Right, that hypotenuse, because we're going to make a right triangle there, yeah. So it'll be
15 times
2 meters
15 squared,
from starting.
A squared plus B squared equals C squared,
Correct.
right?
Correct. So because it's 15,
So that's going to be a 45, 45, 90. So that'd be 15 radical 2 will be the hypotenuse.
Okay. We're going to come back together in a couple of minutes, and we'll go over the answers to see if we get them right. Okay. I guess 30 or 40 seconds, whatever.
So 15 times 15 plus
plus 225 plus 225,
50.
right, which is going to be roughly 21.2 if you do take the square root
It's
of
going to be
that.
what?
21.2, you got to take the square root of that.
$21.2. Huh.
Right.
Okay.
Okay.
30, 40 years.
I remembered the name though, Pythagorean theorem, yay.
I teach philosophy.
Okay.
Theory of forms and the what is true knowledge.
Oh, there we go.
But you didn't tell me, Pam, or we got cut out. Where do you teach?
I teach at Robinson Secondary.
Sorry
Teach
about
at
that.
Robinson.
Okay.
Where do you teach at, Monty?
Thomas Jefferson.
Yeah. You got this. Smarty kids.
I got the very motivated kids.
Yes.
Uh,
With the parents too, I'm sure.
There we go. Okay. All right. I'm looking all over for. Do I have to assign everybody one by one back into the main room? No, there's a power button there. Okay, great.
Yeah, just to stop.
Yep, just hit the stop. Okay. So now, let's talk about how we got for answers. Did we get the answers for these?
I think so.
Group one. What did you get for group one?
I don't know what you're talking about.
I got,
Group one. Yeah,
I tried to add them up,
What's that?
like 35 for the actual displacement, but then I also tried to add them up and square root it and got 25. So I'm really lost, like what's the correct answer.
Okay.
I got 2 answers.
Okay. Well, so there's two things going on here. The first is there's a mathematical question about how do we solve the problem? And then there's the function of we don't actually have calculators, and we haven't done this in forever because it's been a long summer, but also a long 30 years before that since I had to do this for a living in school. So yeah, I understand that. But the basic idea we're going to say is if you went 20 meters north and then 15 meters west, this would be your displacement. We're talking about an actual distance in a specific direction, a displacement in a direction northwest. And how far is that? Well, this is 3 and that's 4, so this is going to be 25 meters because it's a 3, 4, 5 right triangle.
Right.
Okay, so your displacement is 25 meters northwest. That's what's called a vector quantity. It's a direction and a magnitude. We have here a magnitude and a direction, and that equals a vector. If you have to give a direction for the whole motion, it's a vector. Okay, so we can look at a second one, the second question, which looks like this. And I'm going to go on and I'll put this on another page. And of course, the slides will always be available. I'll post those to Google Classroom afterwards so you can download and look at them when you rewatch the video for your own personal enjoyment. If you went 30 meters south, and then 15 east, and then 15 north, we can ask, where did we end up relative to the beginning? where we started, we see that we are 15 down and 15 over from the beginning. So this would be 15 radical 2, because this is a 45-degree triangle because the sides are the same. And 15 times 14 is probably around 210. Because 14 squared would be 200, 15 squared 225, so it's right in the middle. This would be about 210 meters. In what direction? Southeast. Now, as we saw in the lesson earlier today, we could even put an angle on that if we wanted to play around with sine, cosine, and tangent. And we will be doing that next class. You'll hate it, and that's fine. You'll just be doing it all year because it's physics, it's what we do. But you can see how we could do that because we have the side of the triangle. We could put an angle in and say, so it's 45 degrees southeast, it's directly southeast. Okay, and because we can put an angle and a magnitude on there, a magnitude in a direction, it's a vector. If it's not a vector, it's what's called a scalar. Scalar quantity is just magnitude, and a vector is both magnitude and direction. Now, so what the first thing we're going to need to do here is figure out how to identify vectors and scalars, and then how we do math with them. The math is annoying geometry. And this is our quizzes. So let's go do one of these. This is our exit ticket. And this is going to give us some practice identifying which are vectors and which are scalars. Your definitions are right here. Magnitude or magnitude and direction. So let's go there and see if we can do that. Drag me into the quizzes. Oh, that's right. Where is it? Add students. Where'd it go? Quiz. Now, oh crap. That's right. Okay, you're in my Google Docs. Oh wait, no, okay. I think this works.
It's asking for a code for me.
Yeah.
Just say it. And I think I'll.
Yeah, I got it. Okay, I'm looking for my code. Where's my code? I've done this like 3 times already today, and every time it doesn't work. But okay.
Code each time.
Collections, kinematic starter. There's something about how you're supposed to be able to get it in with play live. There we go. Continue.
It's asking me to sign up.
Yeah, here we go. JohnMyQuiz.com. There's my code. Okay.
20402.
Okay, and I got one in there. Hello, Lorax. You may speak for the trees, but not the sprouts. Okay. And this is going to be individuals because I didn't feel like making teams. It's classic. Classic. Yes, classic. Again, ready, set, go. We got 3 out of 4. I don't think I blame you.
This doesn't make any sense. I can't log in.
Oh, okay. Did you go to joinpd.com?
Yeah.
Okay. And the game code is on the main. If you go back to the main
Join PD. I thought it was a vector. I thought there was something else. Quizzes. It wasn't a quizzes?
30 minutes per second.
Are you at the
I went to the quizzes thing that was in the PowerPoint.
Oh, okay. Yep. Yeah, that's the same thing I did earlier. Yep. Yeah. Okay. Yeah, that's on me for not being very good at figuring these things. Yeah, I was worried, but because it seemed like there should be a way to get your classrooms imported in from Google Classroom, but I guess because it's not officially, they don't want to share data like that yet, so you can only do it this way.
Oh.
Okay. But you can group against people if you want, because you can see how they're doing on the main screen if you just come back to the Blackboard window.
Gotta see. So,
Okay. Okay. And yeah. I think there's only 10 questions. So when you get done, we'll come back here and I'll give you the homework. All right, okay. When you're done, you're not giving a heads up or any kind of a symbol. Have to be sad, confused, thumbs up, don't care. All right, there we go. Welcome back, Judith. You're good.
Thank you.
No,
Keep getting disconnected.
I don't know which one you were. I have no idea who you, like, all I can guess is, well, whoever's done first, right? Anyway, the homework will be there on the screen. I've written it down. It'll be posted to Classroom. But the other thing I can do is we'll just go back to stop sharing. And we're all back. Okay, the homework, 1 through 75 odd, sure. Okay. There we go. And that's it for today. I'll post the notes. There'll be a video. You can watch whatever you want to later. Thanks a lot.
Mr. Spang.
Oh, yeah.
Thank you.
There you are.
All right, we survived.
Oh my God.
Hey.
Think about this. I don't know about your schools, but we're doing, kids will be in class 8 to 4 or 8:30 to 4 every day.
I know. It's like 100 minutes each class. Wow.
And we just went through 5 lessons